Hi everyone, welcome once again to our series of 100 most important questions for IPMAT. So far we have solved somewhere around 25-26 questions. Today we are going to solve another 9-10 questions. I gave you some as homework, right? I hope you tried those, and let's get started. And if you are somebody who is preparing for IPMAT 2026, then you can join our crash course. It is starting from 29th of March with live classes. Every day we will be having 6 hours of live classes, 3 classes every day, 2 hours each. Okay, these will be live classes. We will be teaching you the basics, then we will be solving some practice questions, then we will be solving the PYQs. Okay. Apart from that, if you are somebody who is a dropper, or you are somebody who is finishing his or her board exams before 29 March, then you can join right away, because then you will be getting access to all our recorded videos till that time. Till 29 March you can learn from those, and 29 March onwards you can join our crash course. Okay, we will be starting with the live classes. And if you are somebody who wants to practice more, then you can go to our playlist section. There is a playlist named IPMAT Daily Practice Questions of Quants. Okay, we have a lot of questions. Every session has 10 questions solved, very high quality questions for IPMAT Indore, and you can finish these. Okay, there are questions from number system, algebra, geometry, arithmetic, all topics. So this is the question I gave you as homework. Consider a polygon of n sides. What is the number of triangles that can be drawn taking vertices of these polygons as vertices of the triangle, and no sides of the triangle is common with any sides of the polygon. So first of all, there is a polygon of n sides. Okay, suppose this is my polygon. This is a polygon. Obviously, polygon means poly means many, gon means sides. So polygons, in fact regular polygons are very important for geometry as well. Okay, every year one question related to area of regular polygons or sum of all internal angles, something like this is asked around regular polygons. Okay, it is very important from geometry's perspective as well. So do them. Okay, in this question we have a polygon of n sides. So this is a polygon having 6 sides. How many vertices are there? 1, 2, 3, 4, 5, 6. So remember, the number of sides is equal to number of vertices in a polygon. Okay, what is the number of triangles that can be drawn taking vertices of these polygons as vertices of triangles? So vertices of the polygon should be vertices of triangles, and no sides of the triangle common with any sides of the polygon. We have to make sure that whatever triangle we are forming using the vertices of the polygon, it should have no side common with the polygon. Okay, now see, this polygon has n vertices in total, n vertices in total. To form a triangle I need any 3 vertices. So that means the total number of triangles possible, if I choose any 3 vertices out of these n vertices that are in my polygon. For example, I have just taken a 6 sided polygon, 6 vertex polygon. Okay, so out of total n vertices, if I choose any 3, I will be able to form a triangle. Finally, this will be what? Total triangles formed, total triangles possible. Okay, but inside these total triangles possible, we can also have some triangles like this. Suppose I take this as one vertex, this as one vertex, this as one vertex. What will the type of triangle formed? This is the triangle formed. How many vertices, how many sides of the polygons are common with the triangle? This is a triangle, so this side is common, side of triangle, side of polygon. This also side of triangle, side of polygon. This side is not common, isn't it? So this is a triangle which has 2 sides common with the polygon. We do not want such triangles. So that means out of these total triangles possible, we will have to remove triangles having 2 sides common, right? Triangles having 2 sides common with the polygon, isn't it? And we can also have some triangles that look like this. Suppose this is one vertex, this is one vertex. So one side is common with the polygon, and if I now take third vertex here, this is the triangle formed. How many sides of this triangle are common with the polygon? Just one side, this side. This is not common, this is not common, this is common. So we also have to remove such triangles having one side common. Yes or no? Now how to remove these? Okay, let us see how to remove these. We know total number of triangles is NC3. From that we have to remove total number of triangles having 2 sides common and one side common. Let's work with one side common first. Okay, one side common. Suppose this is your polygon. Okay, one side common means, say this is one vertex, this is one vertex, these 2 vertex will form a side. So 2 vertices of the triangle are already there. Okay, Can you take this as the third vertex? The moment you take this as the third vertex, this is the triangle formed and two sides will become common with the polygon of this triangle. So this cannot be taken, right? Similarly, can this be the third vertex of the triangle? No, because 1, 2, 3. If you form this triangle, two sides are common. So this also will have two sides common with the triangle formed, the polygon. This also cannot be taken, right? I hope this is clear. So that means for how many such triangles are possible? There are n such sides, one side. For one such side, how many vertices will be gone? One vertex is gone, this cannot be chosen, this cannot be chosen, and these are already taken, these two vertices are already taken because side has to be formed. So out of total n, there are n sides, one side, two side, three side, four side, five side, six. So there are n vertices, that means n sides. For every such side, how many vertices will we remain with? 1, 2, 3, 4 cannot be taken, that means n minus 4. For every side, there are total n sides. For every side, there will be n minus 4 vertices. Okay, there will be n minus 4. One vertex gone, 2 gone, 3 gone, 4 gone. Because see, if you take this as the third vertex, this is the triangle formed. How many sides does this triangle have common with the polygon? Does this triangle have common with the polygon, or polygon triangle, they have one side common, that is what I want to say, right? So either you can make this triangle or this triangle, yes or no? So out of total n vertices, 1 gone, 2 gone, 3 gone, 4 gone. So every side, for every side we will have n minus 4 vertices, to which we can take as the third vertex of the triangle and form a triangle that has one side common with the triangle. So such triangles will be reduced. I mean, out of total triangles possible, we will have to remove these many triangles, and these are the ones having one side common. I hope this is clear, one side common triangles. Okay. Now let's work upon two sides common. Let's find out how many such triangles are there that have two sides common. Okay. Triangles having two sides common. This is my polygon, for example. Say I take this as one vertex, right? This as one vertex, I have to make two sides common. So let's take two sides, one side, two side, yes or no? If I take two sides of the polygon, this is the triangle formed, and this triangle formed has two sides common with the triangle. This triangle has two sides common with the polygon, polygon triangle have two common sides, okay? One possible. Then if this side, these two are the common ones, then this is the triangle formed. If these two are the common ones, this is the triangle formed. If these two are the common ones, this is the triangle formed. These two are common, this is the triangle formed. These two are common, this is the triangle formed. So what do you see here? If you have to find out total number of triangles having two sides common in an n-sided polygon, such triangles will always be n in number, that means equal to number of sides. I hope this is clear, yes or no? So two sides common wale, there are n such triangles, those will also be removed. I hope this is clear. You can try it with a 5-sided polygon as well. Okay, say this is a pentagon, one side common, two side common, one triangle, two triangle, three triangle, four triangle, and then five triangle, two sides common. Now you just have to calculate the value of this. Okay, let us calculate the value of this expression. So how much will that be? That will be NC3 will be n factorial upon 3 factorial into n minus 3 factorial. So the bottom n minus 3 factorial has to be cancelled with n factorial. N factorial will be n into n minus 1 into n minus 2. N minus 3 factorial from the denominator numerator will be cancelled. We will remain with 3 factorial in the bottom, that is minus 6. Here n is common, n is common. So can I take minus n common? If I take minus n common, what will I get? N minus 4 and then plus 1. So this ultimately becomes n minus 3, isn't it? So this is n minus 3 here. Now this 6, if I take LCM, so this 6 goes here and I can take it like this. N is common here, n is common here. Can I take n common? What do I get inside? I will get n minus 1 into n minus 2. N is common here, we can take minus 6. Minus 6 into n is minus 6n, and minus 6 okay, just a second. N was taken common, right? So minus 6n, and then minus 6 into minus 3 is plus 18, right? And this is divided by 6. What do you ultimately get? You get this n. We have n into n square here. Then minus 3n minus 6n is minus 9n. minus 1 minus 2 is plus 2 plus 2 18 is plus 20 divided by 6. So, that ultimately gives you n into this can be factorized further n into n minus 4 into n minus 5 divided by 6. N into n minus 4 n minus 5 divided by 6, option B is my answer. And you can simply remember that these type of questions can also be checked through options. I mean, suppose this is my answer option B, suppose I check with 4-sided figure. This is a 4-sided figure having 4 vertices. Can you form any triangle here that does not have any side common with the square? See, one vertex has to be taken first, right? We are forming a triangle, we need 3 vertices. Can I take this vertex? No, otherwise one side will be common, cannot be taken. Can I take this? Yes, I mean if I form it like this, I can take it common. But then now I need the third vertex here, right? If I take this as the vertex and this is the only option possible, there will be 2 sides common, isn't it? So, there will be no triangle possible in a 4 vertex polygon that does not have any side common. So, that is why if you put n equals to 4 here, this will become 0. In fact, for a polygon as well, there is no such triangle possible. For a hexagon which has n equal to 6, if you put 6 here, then what do you get? 6 into 6 minus 4, that is 2, 6 minus 5 is 1 divided by 6. There are 2 such triangles possible having no side common with the polygon, okay, in a hexagon. I hope this question understood, very good question, okay. This can come in IPMAT Indore, and if you have any doubts, let me know. Fine. Let us try to solve this question now. This is a question which says if 3 plus 2 root 2 is a root of the equation ax square plus bx plus c equal to 0 and 4 plus 2 root 3 is a root of the equation ay square plus my plus n equal to 0, where a, b, c, m, n are integers, then find the value of this. Now, see, whenever you have a quadratic equation has 2 roots, and what do you see here? This is an irrational root, isn't it? Because root 2 is an irrational number, root 3 is an irrational number. Whenever you have irrational roots, they occur in, you can say that irrational roots occur in pair of conjugates. Okay, I hope you know what conjugates are, not very difficult, okay, sounds complex but very easy. Suppose one root of the quadratic equation is a plus root b, then definitely another will be a minus root b. So, you just have to change the sign in front of the root. So, here also I know that this is my quadratic equation, it has 2 roots definitely because degree is 2. If 3 plus 2 root 2 is 1 root, then another root will be 3 minus 2 root 2, okay. So, this equation ax square plus bx plus c equal to 0 has 2 roots, 3 minus 2 root 2, and the first root was given 3 plus 2 root 2. I hope this is clear. So, they are in pair of conjugates. Before the root sign we just have to put a negative sign. Here also this is my equation, okay. What is the another quadratic equation that I have been given? That is ay square plus my plus n equal to 0. It has one root as 4 plus 2 root 3. Another root will be a pair of conjugate. This has to become a pair of conjugate. Another root will be 4 minus 2 root 3. I hope this is clear. We have been asked the value of b by m plus c minus 2b by n. Whenever you have such conjugate or something in quadratic equation, you always have to, you just have to remind yourself of finding out the sum and product of roots, okay. What is this? B by m, okay, b by m. What can you see here? Sum of roots for this will be, sum of roots in this equation will be, in this equation the sum of roots will be minus b upon a. So, minus b upon a, that is what? Sum of the roots. So, minus 2 root 2 plus 2 root 2 will be cancelled, 3 plus 3 6, yes or no? And if you find out the product of roots here in this equation, it will be c upon a, and product of roots, this is 3 minus 2 root 2, 3 plus 2 root 2, these are a minus b into a plus b, that is a square minus b square. So, 3 square minus 2 root 2 ka square, that is 9 minus 8, that is equal to 1, yes or no? So, product of roots will be c upon a. So, c upon a, product of roots you just found out, that is 1. You have to do the same for this equation as well. For this equation, if you find out the sum of roots, 4 plus 2 root 3 plus 4 minus 2 root 3, 2 root 3, 2 root 3 gone, 4, 4, 8. So, sum of roots will be minus m upon a, that is equal to 8. And what will be the product of roots here? Product of roots here will be n upon a. So, n upon a, and what is the product of roots? 4 4 is 16, and this is 2 root 3, 2 root 3, product is 12. So, 16 minus 12 is 4, yes or no? I hope this is clear. What do you get from here? From here you can say that b equals to 6a, in fact b equal to minus 6a, because this is minus b upon equal to 6, so b equal to minus 6a, okay. Then c equals to a, here m equals to minus 8a, and finally n is equal to 4a from here. Yes or no? You know the value of b in terms of a, you know the value of m in terms of a, you know the value of c in terms of a, the value of b in terms of a, the value of n in terms of a. So, what do you have to ultimately do here? You simply have to find out b upon n ka value, b upon m. So, minus 6a upon minus 8a, so a gone, 6, 8 gone, 3 by 4, this is 3 by 4, b upon m plus c. What is c? C is a minus, b is minus 6a. So, 2 into minus 6, that means 12, minus minus plus 12 and a is 13. So, this is 13 divided by n is 4a. So, 4a cancels. So, 16 by 4, that gives you 4, 4 is your answer for this question. Looks complex but very easy. Remember irrational roots or even imaginary roots, they also occur in pair of conjugates, okay. So, if one root was given 2 plus 3 iota, another will be 2 minus 3 iota, okay. You have to remember this. Now, we have to find out, we have to solve this question, the sum of all possible real values of x for which log this is equal to log this, okay. What do you see here? This is log base x minus 3, log base x minus 3. Here this 2 is alone. In such questions, first of all, try to make the bases of log equal, because you know that log properties are usually helpful when the bases are same. So, this is log x minus 3, okay, log base x minus 3, this is x square minus 9, okay. So, say x square minus 9 only, okay, for now, and this is log of base x minus 3, this is x plus 1, this is 2, this 2 cannot be directly added with these logs, right. So, how can I do it? I know that I have to make a log out of this having base x minus 3. So, what can I do with this log base x minus 3 so that ultimately it gives value to? Obviously, x minus 3 ka square, isn't it? Then and only then it will be added, right? Now, what should I do? Either I can bring all the logs here, hai na? So, say log x minus 3 is here, this is x square minus 9, this log comes here, so this is minus log x minus 3 into x plus 1, and this is minus log. See, I can do one more thing. In the right hand side, we have log this base x minus 3, log this base x minus 3. So, log, if the logs are being added having same base, they can be multiplied, isn't it? So, can I simply write this part as log of x minus 3 here, and then can I simply multiply x plus 1 and x minus 3 square? I can do that, isn't it? So, instead of bringing these two here, I mean, I'll first write this in the right hand side like this only, and then let me take this to the entire left hand side. So, I'll get log x minus 3 x plus 1 into, over here I'll straight away do x minus 3 square, and this is equal to 0. Yes or no? Now, again there are two logs having base x minus 3, but there is minus sign is between. Log a minus log b having same base, we can write it as log a by b, isn't it? So, over here let me write this as log base x minus 3. This can be written as x square minus 9. X square minus 9 can further be written as, this is a square minus b square, x square minus 9, it can be written as x plus 3 into x minus 3, right, upon this will go here in the bottom, x plus 1 upon x minus 3 ka square, and that is equal to 0. I hope this is clear. So, x minus 3 and square is gone, right. What am I left with? I am left with this, okay, log x minus 3, and this is equal to 0. So, what do you get? Log of some value is equal to 0. When is log of some number equal to 0? Log 1, right. For any base, log 1 is equal to 0. So, that means I should care about this part, yes or no? X plus, see this log to exist, for this log to become total 0, this argument should be equal to 1. So, that means I have to first put x plus 3 upon x plus 1 into x minus 3 equals to 1. But there is one more thing which we have to take into account. This x minus 3 is not here just to roam around, okay. It has a great importance. Base of a log, base and argument of a log should never be less than 0, yes or no? So, it should be greater than 1. So, we will check later whatever value of x we get from here, if we put it here in place of x, the base should be positive, okay, greater than 0. So let me solve this. X plus 3, this cross multiplies here, we will get x minus 1 to x minus 3. So that means x square minus 2x minus 3. If we solve this further, x square minus 2x, sorry, minus 3x, okay, we take this to the right hand side, minus 3x minus 6 is equal to 0. Yes or no? This is the quadratic equation, we cannot factorize it. Let us find out the roots using Shvetacharya formula. X equal to minus b, so minus b is 3 plus minus under root of b square minus 4ac. b square is 3 square 9 minus 4ac. So 9 plus 24 is 33 divided by 2a, so 2. So there are two roots here, see 3 plus root 33 by 2 and there is 3 minus root 33 by 2. What do you see here? One root is this, one root is this, but this 3 minus root 33 is 5 point something. So 3 minus 5 point something is negative, negative by 2 is negative, this is negative. This value of x is negative, isn't it? And this is actually how much? See, just do the approximation. 3 minus root 33 is somewhere around 5.5, okay. In fact, more than that, it is very close to 6, okay, because root 36 is 6. So this divided by 2, how much do you get? This is minus 2.5 divided by 2, that means minus 1.25. So this is minus 1.25, this is the value of x. If you put x equal to minus 1.25 here, then negative negative, this is going to make the base negative, yes or no? This is going to make the base negative, so this cannot be accepted, right? While this 3 plus root 33 by 2, this becomes 3 plus root 33 say 5.5 divided by 2. So this becomes 8.5 divided by 2, that becomes 4.2 approx, yes or no, 4.2, 4 point something. So this is the value of x that is coming through this root. If you put x equal to 4 here, the base is positive. So that means only this value of x will be acceptable, option C, nothing else. This is discarded, okay. I hope this is clear. Now students do a big mistake here. What they do is, obviously they are able to solve this log thing, they are even able to get this equation, but here in this quadratic equation, when they need to find out the sum of roots, they do not check the roots individually because they forget about this x minus 3. They usually know that this is the root, this is the equation, it will have two roots, sum will be minus b upon a, so minus into minus 3 upon 1, that is 3. They usually mark 3 as the answer. Many of you would have committed the same mistake, but in log questions you have to be, you should have your focus upon the values of base and argument, they can never be negative, okay. I hope this is clear. Now let us talk about this question. In a class of 150 students, 75 students choose physics, 111 choose mathematics, 40 choose chemistry, all students choose at least one of the 3 subjects, okay, and at least one student chooses all 3 subjects, okay, at least one student chooses all 3 subjects. The number of students who chooses both physics and chemistry is equal to number of students who choose both chemistry and mathematics, and this is half the number of students who choose both physics and mathematics. The maximum possible number of students who choose physics but not mathematics is. This is a question based upon Venn diagram optimization, not very difficult, okay. Let me show you. We know that there are 3 subjects, physics, chemistry, maths. Let us make 3 Venns for them, okay. 3 Venn, then you have to make this. In a class of 150 students, that means we are talking about 150 students, 75 choose physics. Let me say this is physics, this is chemistry, this is maths. 75 choose physics, 111 choose mathematics and 40 choose chemistry, okay. All students choose at least one of the 3 subjects. Every student is choosing at least one of the 3 subjects. So there is nobody who is not choosing anything. So that means this region outside the 3 sets, what is this region called? This is called no physics, no chemistry, no maths. So there are 0 such students. That is what this line says, okay, that all students choose at least one of the 3 subjects and at least one student chooses all 3 subjects. Where do we have the region of all 3 subjects? All 3 is this region. So this has minimum 1 value. So let me put minimum 1 over here for a while. Just keep in mind that this is minimum. It cannot be less than 1, okay. Okay, the number of students who choose both physics and chemistry. Both physics and chemistry is this one, this part entirely, its value is not given. The number of students who choose both physics and chemistry is equal to number of students who choose both chemistry and mathematics. So let me say this is x. So as soon as he says that the number of students who choose both physics and chemistry is this region, he did not say only physics and chemistry. If he would have said only physics and chemistry, that would have been x, but he says physics and chemistry. So the intersection of physics chemistry will be taken, that is x plus 1. So, the other region is equal to number of students who choose both chemistry and mathematics. Now, chemistry and mathematics region will also be x plus 1. So, chemistry and mathematics, this region total also has to become x plus 1. So, obviously done, right. And this I mean x plus 1, we were getting x plus 1 for these, right. This is half the number of students who choose both physics and mathematics. Physics and mathematics is this entire region is physics plus mathematics. So, double of x plus 1 is, what is double of x plus 1? That is 2x plus 2. So, the total region of physics and mathematics should be 2x plus 2. This is 1 already. So, this will be 2x plus 1. Then only this becomes 2x plus 2. The maximum possible number of students who choose physics but not mathematics. Physics but not mathematics. Physics but not mathematics. We have to completely remove the set of mathematics from physics. So, that means we need the combined maximum value of this region and this region. I hope this is clear. Okay. I hope this is clear. You have to maximize this. Please remember, we are talking about the maximum possible value of number of students who choose physics but not mathematics. Physics but not mathematics, that means only this region will be gone, okay. We are actually trying to find out the value of maximum value of this region, the one that I have outlined in green. If you want to maximize this, everything else should be minimized, okay. So, if everything else has to be minimized, then let me try to minimize this region, okay, this region, because see here this is x, this is 1, this is x. About this region, because maximize karna means you have to shift all the values to this green region. So, that means we have to minimize all others. What can be the minimum value of this region? We know that we were given that all students choose at least one of the 3 subjects and at least one student choose all 3 subjects. So, the minimum value that can be given to this will be 1, right? Yes or no? Because all students choose at least one subject. If you put 0 here, that means there is one student who is choosing, who is not choosing. There are some students who are not choosing anything, right? Because you cannot put 0 here. Yes or no? Because there would be, you can say there would be no student who chooses only chemistry. So, this has to be minimum 1. If this is minimum 1, can I calculate the value of x from here? X plus 1 plus x plus 1 should be 40. So, x plus 1 plus x plus 1, x plus 1 plus x plus 1, total region of chemistry is 40. So, that should be equal to 40. So, x will be equal to what? I mean x plus 1 will be 20, x will be 19. I am getting x equal to 19. If I am getting x equal to 19, let me put 19 here, 19 here. This should be 19 into 2 plus 1, that means 39 here, isn't it? The moment we do this, because we have minimized this, it automatically ensures that all the bigger values have been shifted to this region. And if they have been shifted to this region, we actually need to find out the value of this plus this now. This I already know 19, I need value of this. I know the total value of physics is 75. So, this is 19, this is 1, this is 39. So, out of 75, if you reduce this 19, this 1 and this 39, this 1 and this 39, what do you ultimately get? 75 minus 39, 19 is 58, 58 and 1 is 59, and that simply means you will be getting 16, yes or no? 16 as the value of this region will be 16, but you wanted the maximum value of these two regions combined. So, that will be 16 plus this 19, that means 35, 16 plus 19, that gives me 35, 35 will be the answer to this question. It is not an easy question, okay, not an easy question, but it is something which is shifting, related to shifting of values here and there, yes or no? I hope the logic was clear. If you have any doubt, let me know, okay. We will solve more such questions. Now, the question is, triangle ABC has 3 different integer side lengths, side AC is the longest side and side AB is the shortest side. If perimeter of ABC is 384 units, what is the greatest possible value of AC minus AB? AC is the longest side, AB is the shortest side. So, longest minus shortest, mod of this, that means we need the net value of this. Obviously, it will be a positive quantity because from larger you are deducting a smaller value, isn't it? So, let me say that I have a triangle, okay. like this. This is the longest side, this is the smallest side, this is the second largest, let me call it medium side, okay, shortest, longest, medium. You know that the perimeter is S plus M plus L and that should be equal to 384. What does it want? What is the greatest possible value of AC minus AB? That means we have to maximize AC, we have to minimize AB because we have to find out a difference. So, AC must be maximized, we need this as big as possible, and AB is, because it is the shortest, AB is the shortest, right? Yes. So, AB should be as minimum as possible, right? This is our ultimate aim. So, in one way we can say that AC is the longest side. So, AC is my longest L. We have to maximize the value of the longest side while we have to simultaneously minimize the value of the shortest side. Now, you know that in a triangle there is an inequality, right? I hope you remember the triangle inequality. There is A, B, C. If these are the three sides of the triangle, then sum of lengths of any two sides should be greater than the third side. You remember this, isn't it? So, my length of the longest side, right, it should be just smaller than the sum of the other two sides, yes or no? L should be smaller than S plus M. So, if we want the largest value for L, if we want the largest value for L possible, L here, which is the longest side, it should be just less than S plus M. So, what is the next value after S plus M? Because see, there are integer lengths, okay, these sides are integer lengths. So, shouldn't this L be equal to S plus M minus 1 if you want to give the maximum value possible to L? So, L should be just smaller than S plus M. So, that is the reason L should be S plus M minus 1. Great. So, can I put this over here? Because this is what we have to do to find out the or give the maximum value to L. So, S plus M plus L will be S plus M minus 1 and that should be equal to 384. We can say that 2 times S plus M should be equal to 385 or S plus M should be equal to 192.5. But because these are integer lengths, then we should say that S plus M should actually be equal to 192. Yes or no? Yes, we cannot take 192.5, not more than that. We should be able to take it around 192. Yes or no? So, if S plus M is 192, can you say that L is equal to S plus M minus 1? Because that is the maximum value possible for L. Yes or no? So, S plus M is 192, 192 minus 1, that is equal to 191. This is the length, longest length that you can give to L. This is the longest side of the triangle. Okay, 191. You have maximized the longest side. Simultaneously, you want to minimize the shortest side, which is AB. Now, we also know one thing in this triangle, that is S is the smallest side, then we have M and L is the longest. Can I use this relation? If I say that M is less than L, can I say that M is less than L is 191, yes or no? So, M will be less than 191, but we have to deal with the value of the shortest side. So, let me just convert the value of M into S. If I convert M into S, M will be what? M will be 192 minus S from here. So, M will be 192 minus S less than 191. Now, what do you have to do? You have to, if you solve this, what do you get? S is greater than 1. If S is greater than 1, what can be the integer value of S greater than 1? That is S equal to 2. You have got S equal to 2, L equal to 191 and L plus S plus M should be totally equal to 384. So, 191 plus 2 is 193. 193. So, that means M should be equal to again what? 191, because it's 3 because obviously I mean the perimeter is 384 in total. So, according to L 191, S greater than 1, which we took to M should be 191, then only perimeter will be 384. But is L actually remaining the longest? The moment M becomes equal to 191, this does not satisfy, isn't it? So, then this is gone. So, what is the next value of S that we can take? Can we take S equal to 3? If S is equal to 3, L is equal to 191 that we have found out, M should be equal to what? 190. Then the perimeter is 384. And are these satisfying the triangle inequality? Sum of these two should be greater than 190, these two should be greater than 3, these two should be greater than 191. Yes, triangle inequality is perfect. L is greater than M is greater than S, that is also being satisfied. Everything is being satisfied. We have got the largest value of L, which is AC, that means 191. The smallest value of AB, that is 3. If you find out the answer, it will be 188. I hope this is clear. This is a difficult question, okay, not an easy one, okay. But I hope you know how to use the triangle inequality in such questions, isn't it? Now let us try to do the 28th question. The equation 11x plus 67y equal to 133 has option A 2 integral solutions for 0x between 0 50, no integral solutions for y between 10 20, and integral solution for x between 100 200, no integral solution for y less than 0. Let me tell you one thing, okay. This is 11x plus 67y. So in IPMAT, I mean, you just cannot win if you are only good at applying formulas, recalling things. Some sort of calculation should also be good, okay. What do you see? 133, here you have 67. Can you tell me any such value of x and y for which the sum is 133? Yes, 67 plus 66 will be 133, so you have to make this 66. That is possible when x equal to 6, y equals to 1. So x equal to 6, y equal to 1, the total will be 133, yes or no? The question says the equation this has integral solution. Integral solution means integer solution. That means we are not just concerned about positive solutions, either positive or negative, okay. And what are the ranges given to us? This is positive value of x, positive value of y between 10 20, positive value of x between 100 200, and y has a negative value, okay. Always remember one thing, whenever you have such equations, linear equations, and you get one pair of solution, then always remember the values of x that will satisfy, they will be in a gap of coefficient of y, while the values of y that will satisfy, they will be in a gap of coefficient of x. So that means if you want the next value of y that will satisfy this equation, it should be in a gap of what? Coefficient of x, that is 11. That means from 1, this is the solution that you have got. From 1 you can go either 11 above or below. If you go above, that means you add 11 to this, you will get 12, while if you subtract 11 from this, you will get y equals to minus 10, yes or no? The moment you get y equals to 1, y equals to minus 10, y equals to, I hope you understood the logic. I am saying that whenever we have linear equation like this, if you have got one solution, this is the solution that you have got, then there is a shortcut which says that the next set of solution of x and y that will satisfy the equation, value of y will always be in a gap of what? Coefficient of x, while the value of x that will satisfy, it will be in a gap of coefficient of y. So what will be the value of x that will satisfy? Coefficient. Look at the coefficient of y, that is 67. 67 what? If one value is increasing, the other decreases, okay. So that means you have to decrease 6 by 67, that becomes minus 61, yes or no? This is how the solutions will go around. So let me put x equal to 6, y equal to 1, and you have got another, that is x equal to minus 61, y equals to 12. What do you see? X is decreasing by 67, y is increasing by 11. So the next value of y that satisfy should be in a gap of 11, that means 23, then y equals to 34, and x, value of x will keep decreasing. So that means minus 67, that means minus 128, right. Then x equal to minus 128 and 67 is 195. And before this, I mean if you go up, it is increasing by 67, so x will be 73, x will be 140, x will be 207. Value of y keep decreasing it by 12, so minus 10, minus 21, minus 32. Let us match the options now, that is, they will give us a good idea. Do we have two integral solutions here between x equal to 0 and 50? Are there two values of x between 0 and 50 that are satisfying? No, there is only one value between 0 to 50 of x that is satisfying the equation, that is x equal to 6, hence this is wrong, okay. No integral solution for y between 10 to 20. Between y 10 to 20, is there no integral solution? No, there is a solution at y equals to 12, y equals to 12 is between 10 20, there is a solution. So this is also wrong. An integral solution for x between 100 to 200, between x equal to 200 and 200, what do you see? Is there an integral solution? An integral solution means 1. So between 100 to 200, there is only one value of x that satisfies. Yes, this looks true. Yes or no? No integral solutions for y less than 0. No integral solution for y less than 0. This is incorrect. Obviously, y less than 0. There are so many solutions. So, this is also wrong. This is how you have to find out things. I brought this question because I wanted to tell you this trick, okay, that this is how the solutions occur. Now, we have the next question, again a very good question, okay, which says if log 36 factorial base 6 minus log 34 factorial base 6 is equal to log 6 y factorial base 6 and this, okay, let us calculate the value of x plus y. So, what do you have here? Log this minus log this, that means base is same. So, log a minus log b is log a upon b. So, log 36 factorial, see base will be 6 only, 36 factorial when written will be 36 into 35 into 34. So, 36 into 35 into 34 factorial upon 34 factorial, 34 factorial, 34 factorial will be gone, okay. And on the right hand side we have log 6y factorial. So, log base 6, 6y factorial, 6y factorial upon x factorial. This is what we have to do, okay. Now, what can be done here, okay. So, that means this log has same base, this log has same base, that means their argument should be same. So, 36 into 35 should be equal to this, isn't it? 36 into 35 should be equal to y factorial upon x factorial into 6. 6 cancels this 6, this becomes 210. Let me solve it here now. 210 equals to y factorial upon x factorial. Are there any values of x and y for which we get 210? 210 can be written as, it is divisible by 5, 42. 42 can be written as 237. So, 2357, 35 into 6, 210, correct. Yes or no? Y factorial upon x factorial. See, this is very logical. Most of the students will be stuck over here. We need such value of y and x so that this is what we get. What is missing from this? This looks like a factorial, isn't it? What is factorial? Factorial basically, suppose you write 6 factorial. It is continuous product of 1, 2, 3, 4, 5, 6. Yes or no? This is factorial, isn't it? So, here also we want some sort of factorial will be formed. Can I put 1? Does not make any difference. What do we have missing from this continuous product of 1, 2, 3? 4 is missing, 6 is missing. Yes or no? So, that means if this y would have been, y factorial would have been 7 factorial, and from this 7 factorial, if we have to subtract what? If we have to cancel 4 and 6, 4 and 6 become what? 24. See, in this product 4 and 6 are missing. So, 4 and 6 are like 24. How can 24 be written? 1, 2, 3, 4. This is the way in which 24 can be written. This is 1, 2, 3, 4 is basically what? 4 factorial. So, that means if 7 factorial upon 4 factorial would have been there, then the value of y factorial upon x factorial would have been 1, 2, 3, 5, 7. So, y is 7, x is 4. We have to find out the value of x plus y, that gives us 11. 11 is the answer. Good question, okay. Basic, but yes, logical. I hope this is clear. Now, we have this question. This is your homework, okay. This is your homework. Let us try to solve this question, okay. I will solve this, the other two we will discuss in the next class. So, sum of digits of the number this into this. See, obviously it looks very complex, but we have to find out sum of digits. 625 is something related to 25, 25 is purely related to 5. So, can we say that 625 is 5 ki power 4? This is what you have to think over there, okay. 128 is a very familiar number, it is 2 ki power 7. So, when you solve this, it becomes 5 ki power 260 into 27, 2 ki power 7 into 36 is 252. We know that if I multiply 2 and 5, I get 10. So, 2 into 5, 2 into 5, the maximum power I can take common is 252. There will be some powers of 5 which are extra, 5 to the power 8, isn't it? Because 5 ki total power is 260, 2 ki total power is 252. 2 into 5 is 10. So, that means there will be 10 ki power 252, 10 ki power 252. 10 ki power 252 will eventually have one digit as 1, while there will be 252 zeros. Yes or no? The other one, 5 to the power 8, this is going to matter a lot. 5 to the power 4 is 625, right? 5 to the power 5 is 3125. 5 to the power 6 is 15625, isn't it? You just have to multiply 2 more 5s with 5 की power 6. So 15625 into 25. If you have an on-screen calculator, you can simply use that to multiply 15625 into this, or otherwise you can multiply 5 8 times. What do you eventually get? You will be getting 390625. So my answer is actually going to be this much, 390625 into this. What do you get? 390625, and then we just have to put a lot of 0, 252 times here. Yes or no? These zeros will not be contributing to the sum of the digits, only these matter in sum of digits. 3, 9, 12, 12, 6, 18, 18 into 5 is 18 plus 5 is 18 plus 7 is 25. 25 is the answer. That's the answer. Okay. This is a CAT PYQ and it was not that difficult. I hope you enjoyed the session. If you have any feedbacks, let me know. Solve the homework questions and we'll meet in the next session now. Thank you so much.